Okay, so this is the last section that we're going to cover in Chapter 1. So it is our last review section. Now, that doesn't mean that there isn't anything else to review. There are other sections in Chapter 1. I just hit the ones that I felt were most important. You should take some time to go back through Chapter 1 and take a look so that you can make sure that you have everything you need to be successful in the remainder of this course. We're going to look at inequalities. Last section we looked at equations, and now we look at inequalities. We're going to solve linear and nonlinear, absolute, and then we're going to look at some modeling with inequalities. Okay, so some problems lead to inequalities instead of equations. So that's when we're looking at everything that's smaller than something, greater than something, smaller than or equal to, or greater than or equal to. To solve an inequality contains a variable means to be able to find all the values of the variable that make that inequality true. Unlike an equation, an inequality generally has infinite number of solutions. Sometimes it has a set of solutions. So here's an equation where we have the answer being 3, and down here is an equation that we have 3 or less than. So less than or equal to 3. Notice the 3 is filled in at the dot. That means it includes 3. To solve these inequalities, we use rules to isolate the variables on one side, and these rules, the symbols A, B, and C, will stand for real numbers or algebraic expressions. And here, the rules for inequalities will involve the symbol, inequality symbol. Now, if you read it from left to right, it's less than or equal to. If you read it from right to left, it's greater than or equal to. Okay, here's some properties for inequalities, like equations. You can add to both sides, subtract from both sides. If you multiply both sides of an inequality by a negative number, then you're going to flip the sign. So this one, notice if you're multiplying by a positive number, it stays the same. But here, if you multiply by a negative number, you flip the sign. Paying special attention to rules 3 and 4. We can multiply or divide both sides by an inequality by positive. Again, the inequality symbol stays the same. But if you multiply both sides by negative, then you have to flip your inequality sign to the opposite direction. Let's look at linear inequalities. Let's solve the inequality 3x is less than 9x plus 4 and sketch a solution set. So we're going to want to get the x's on the same side of the inequality. So here we're going to subtract 9x from both sides and move that over to the other side. When we do that, we will have negative 6x is less than 4. Now I see I need to divide both sides by negative 6, or you can say multiply both sides by negative 1/6. And since you are multiplying or dividing by a negative, then you're going to have to flip your sign. And notice the sign went from less than, reading it from right to left, to greater than. Finally, we simplify. Now, when we put that onto a real number line, notice we only had greater than negative 2/3, so the circle is open circle, and then we shade everything to the right. So from negative 2/3, but not including negative 2/3, to positive infinity. And whenever we use this interval, remember this is interval notation. We talked about this before. This parenthesis means that we start right after negative 2/3. It doesn't include it. and then it goes on to infinity, and the infinity symbols always have a parenthesis because they are considered to be unbounded. Solving nonlinear inequalities. So the guidelines to solving nonlinear inequalities are, first, you want to move all the terms to one side. Then, if you can factor it. You're going to find the zeros if you factor it, and that way you can kind of separate the table or diagram into sections, and then you're going to test each section to see if it works, and then finally solve. So let's take a look at what that looks like. Here we have an inequality. We're going to want to move our 5x and minus 6 over to the other side. So we will subtract 5x and we will add 6. So now we have this. Now, if I look at this, I say factors of 6, then I add to get 5. And the signs are the same, and they will both be negative. So there's my factor. Now, if I look at the inside of this, x minus 2 equals 0. If I solve that, I will get 2. So that tells me that 2 is going to be one of my sections. And then do the same thing with this side. And when I solve x minus 3 equals 0, I get 3. So 2 and 3 on the number line are points where the behavior may change. Okay, so 2 and 3, that's what we just said. So here we have 2 and 3. And we have it as closed circles because that was the inequality that we used. So I want to test from negative infinity to 2, from 2 to 3, and from 3 to positive infinity to see if it would work in my inequality. So you're going to make a table or diagram, and you're going to pick a test value that's in between these areas. So here we picked 1, 2 1/2, and 4. So if I substitute 1 into the inequality, I get 1 minus 2, which is negative 1, and I get negative 1 is less than 0. Is that a true statement? It is true. So as long as it's true, that means that it's part of the solution. Here I have x minus 3, so I'm going to plug 1 into there, and I get negative 2, which is less than 0, which is also true. Negative 2 is less than 0. So both factors are negative, so we need to check one value to test because for each interval, x minus 2 and x minus 3 do not change the sign on any of the 3 intervals we found. So I check here, I get a negative value. I check here, I get a positive value. And I check here and I get a positive value. And I check the x minus 3, I get a negative and a negative and a positive. If I multiply these together, I get positive, negative, and positive. Now, I really think this is a longer way of doing it. I think you can just put this part into the table, and you can be able to understand that if I pick my value and put it in here, I'm going to get positive. If I pick my value between 2 and 3, I'm going to get negative. And if I pick my value between 3 and infinity, I will get positive. So if this confuses you, we can go over some of these in class. Okay, so now that I know that this is positive, negative, and positive, and the vertical lines indicate the points in which the numbers are that will give us 0 on the bottom, I see that x will be greater than or equal to 2 and less than or equal to 3. You read this from inside out. So greater than or equal to 2 or less than or equal to 3. And it's included there because we have the inequality symbol with the equal sign, so we're going to have closed brackets. And this is how we would graph that right here to show our solution. Sorry, my crazy little circle. All right, absolute value inequalities, a little bit different here. So if I have less than a value, I'm going to look at in between. If I have less than or equal to a value, I will look at in between with my parts filled in because I'm including my areas that I'm checking. If it's greater than, I'm going to have a split graph that looks like this. If it's greater than or equal to, it will include the point as well. So here I have less than 2. X minus 5 is less than 2. So that means I'll have x minus 5 from the center. X minus 5 is greater than negative 2 and less than 2. Now, some people like to write this separately. X minus 5 is greater than 2. And I'll put the other one over here. X minus 5 is going to be, oh, I'm sorry, greater than negative 2. Let me put the negative there, reading it this way. And then x minus 5 is going to be less than 2. And solve them from here. Or you can do it this way, whichever one you're more comfortable with. Okay, here they just added 5 to both sides, not showing much work there. So the solution is greater than 3 and less than 7. Geometrically, the solution set consists of all numbers x whose distance is from 5 is less than 2. So we can see the distance from 5 is going to be less than 2, will be from 3 to that 5, but not including 3, and from 7 to 5, but not including the 7. And that's how we get the answer, or can understand the answer, I should say. All right, modeling with inequalities. Modeling real-life problems frequently lends to inequalities because we're often interested in determining when one quantity is more or less than another. Here we have Plan A with a $5 entrance fee and 25 cents each ride, and here we have Plan B with a $2 entrance fee and 50 cents each ride. We are asked for the number of rides in which Plan B is less expensive, or Plan A is less expensive than Plan B. So these are our equations. So we have 5 plus the quarter times the number of rides and $2 plus 50 cents times the number of rides. Now we can set up a model with plan A being less than plan B. And we're going to solve for x, getting the x's on the same side. So I actually subtracted 0.25 x from both sides. Sometimes I feel like I can write really good with this little stylus, and other times I think it looks terrible. This is one of those terrible times. Okay, so I subtracted the quarter from both sides, and then I get this, and now I'm going to divide by 0.25, and I get x is greater than 12. Remember, you are reading from right to left, so this now says greater than. Okay, and that should be about it. So if you plan to take more than 12 rides, plan A is less expensive.